My second semester project was to test hydroponics and traditional gardening. I decided I wanted to see which would be better, planting in soil or planting without soil. So, I observed that the way we are gardening now is an unsustainable practice. I say this because when I observe someone tilling their soil garden so they could start planting or watering their lawns, they're washing away soil. The topsoil just goes away. And it doesn't necessarily come back right away. We have to wait a while for the topsoil to rebuild itself, but we're not giving it a chance to rebuild. That's the problem I observed. So I thought, why not just try growing without soil? And that's what hydroponics is. It's growing without soil. So here's a picture of a hydroponic system. You can see there is no soil down here. This is all water. Versus this is growing outside in the soil, which is typical. If you would like to read my observations page in great detail, please feel free to come and read this page. On to the hypothesis. I have actually prepared a short video on my hypothesis page that I would like to show you now. Before I wrote my hypothesis, I went back to my observations page and reread my problem. Then I went and I researched this problem a bit more, and I discovered the cropland we grow most of our food on constantly shrinks by a significant amount each year. And this can be a problem because if we keep shrinking the amount of soil that we grow our food on, we're going to run out of room eventually to grow food. And this land is shrinking because the topsoil gets swept away much faster than it can be replenished by. And we're doing this by digging up the soil, exposing it to the air, planting crops, and we keep constantly doing this, digging up soil and digging up soil. We're not giving the soil enough time to replenish and recharge its nutrients, and we're also not giving it enough time to settle back fully into the ground so the wind can just blow it away, and therefore topsoil is no longer in the area and we have to move on and find different cropland. I discovered that hydroponics can be a good solution to this issue because hydroponics doesn't use land, it doesn't use soil. So you would not have to worry about eroding away your topsoil because you wouldn't be digging it up in the first place. A constant growing and cultivating process would be possible with hydroponics because unlike soil, you would not have to wait for the nutrients to recharge in the soil. You could just add nutrient solution as often as you need to. So the plant can grow constantly and you can plant more crops as soon as you want to. Hydroponics can save water because plants don't absorb all the water right away. So you can collect the excess water and recirculate it through the system. Unlike traditional methods where if you wanted to collect the excess water, you would probably have to wait for the water to filter through the soil before you could collect it. I found in my research that plants generally grow faster and healthier in hydroponic systems. And this is because they don't have to waste any energy extending their roots through the soil and digging through the soil to find the necessary nutrients that the plants need to grow. I want to prove 3 things with this experiment. The first thing is I want to prove hydroponics can be used to reduce topsoil erosion. The second thing I want to prove is that hydroponics can conserve water compared to traditional methods of growing soil. And the third thing I want to prove would be which method for the gardening plants would grow the best. And I would base this on physical size and the number of leaves each plant produces. So then my hypothesis for this experiment would be if hydroponics can be used instead of traditional gardening methods, then the amount of eroded topsoil would be reduced the amount of water used will decrease, and the plants would grow bigger with the most leaves.
So there is my video explaining my hypothesis. If you would like to come back and look at my hypothesis page, because I have added some pictures and improved it a little, you may come back. It's not like you watch this video and you can never ever go to any other pages. Feel free to explore. For my experiment, I needed many different materials to set up the hydroponic system. For my system, I used an old 10-gallon fish tank that I found in my basement, and I modified it for hydroponics by using air pumps and air stones that you can see in the picture over here. Here are the air stones, and this is the air pump. And that's just so that oxygen can be in the water, and so the oxygen is available to the roots, and the roots of the plants can have oxygen available to them and grow a little faster. But before I could start this experiment, I had to wrap the tank in some paper just to prevent algae from forming on the sides of the glass, because the algae would upset the nutrient balance, the pH balance, and the oxygen in the water. For the top of the tank, you can see over here the pink up there. That is just styrofoam that I use. I cut 4 little holes in them so that the little pots can sit on top of the water and still be floating on top of the water, so then the plants can reach the water a little bit better. For all of the hydroponics related items that I could not find around my house, like the little netted pots and the nutrient solution down here, I went to the Garden Doctor, which is a hydroponics store on 28th Street, and here I have been so kind as to put their website right there. So if you wish to start your own hydroponics thing, you may check out their website and see where you can get started. So hydroponics is a soil-free growing, so you would need something to keep the plants in place, and that's where I got the perlite from. It's just white, kind of foamy growing medium that you would find most of the time in like garden soil, because it can hold water really well, which makes it good for hydroponics. And it just holds the plants up, pretty much. So in the control group, I have 4 pole bean plants planted in soil, and I have, in my experimental group, 4 pole bean plants planted in hydroponics. Collecting the data, I collected the data twice a week for 4 weeks. Each time I collect the data, I measure the plant height and the soil height, the number of leaves each group has, and the amount of water each group used. So, going on to my results page. Now, if you would like to go over these charts and graphs in great detail, you may take some time to come back and go over these. So, that was my control group data. This is my experimental group data. Now, when you can see the control group graph, there are many consistencies among the 4 plants. There aren't very many outliers, except when you get to the very end over here. Some of the leaves are just gone. They died, unfortunately. Same thing in the experimental group, consistent most of the time. There aren't many outliers until you get to the very end. The leaves start to die away again, which is actually kind of weird that the same number of leaves died in the control group and the experimental group. I find that a little strange. Moving on, comparing the height. When we averaged all of the data from the 4 plants in each group, you could see that the control group has a general trend of increasing height, where the experimental group has a general trend of kind of staying the same, kind of decreasing a little bit. So that is clearly visible on this graph. When we compare leaves, you can see the same thing. When we average the data from each group, you can see the general trend of growing leaves for the control group increased and then decreased. And then the experimental group, increased and decreased around the same time period. They just didn't grow as many leaves as the control group did. Soil levels. So, the experimental group does not have any data on this graph because hydroponics does not use soil. Therefore, you cannot measure soil levels on something that doesn't have soil levels. Interesting. So, for the control group, this just shows that the soil levels had a general downward trend among each of the plants. And this analysis paragraph is pretty much summed up in what I just said, but you may always go back and read this paragraph if you feel that I did not cover it to the best of my abilities and you wish to read what I wrote. Now, off to the conclusion page we shall go, where I must unfortunately inform you that part of my hypothesis must be disproved, because if we look at the data, we can see that the plants in the control group that grew in the soil did grow better than the plants in the hydroponics tank, because the plants in the control group were taller, they had a greater height and a greater growth increase, they had greater overall growth, and they had more leaves and a bigger growth rate. The part of my hypothesis where I claimed water would be saved is a bit, tricky to prove or disprove whether or not that is a valid point. I feel that if I had a long time to prove this, I would be able to give a definite answer. But considering I only had 4 weeks for this project, I can say that there was no additional water needed to be added to the hydroponics tank when I needed to add water twice a week each week for the control group. So we can say water was saved in that account. I can prove topsoil erosion was reduced because, as you can remember from my result page, the trend of the soil levels had a downward trend indicating that the control group soil levels were decreasing. The erosion from the water was washing the soil away. We presented this project to our local community, and by we, I mean me and my friend Tyler Van Eck, who his website is right here, so conveniently placed if you wish to visit his project and see what he did, because we have similar projects. We traveled to Sandy Hill Elementary, and we presented our project to a second grade class, and we taught them hydroponics. It was their first encounter with hydroponics, and they thought it was really interesting, and they had many questions. They weren't quite sure how plants could grow outside of the soil, and we explained to them that if you have the right nutrients added to the water, then plants could grow outside of soil and in water using hydroponics. And they decided that this would be a good experiment to use if they had the resources and the time, and they could set it up correctly, and they would like to try it for themselves to see if they could prove the same things. So that is my experiment. I hope you enjoyed this video, and I hope you enjoyed this experiment. I hope you learned something, and thank you for stopping by.